20 years ago, when together with Mike and the whole group of students from University of Berlin, we went on excursion to Switzerland, and we had the chance to walk through the mountains together with Vortrag Conzett and to his Tafosina stack, and it was not only really seeing this impressive structure together with him, but also on the way up there, being pointed out all the little, quite often overseen examples of engineering structures and how to treat them, how to look really careful in that. So I'm really looking forward to the experience you're now sharing with us, if it is when it is useful or when it is harmful. Thank you so much for being here.
Hello, and thanks for the invitation. So, who am I? I may say I'm an experienced engineer. And this self-assuring attitude of being an experienced engineer lately was troubled. And I tell you why. This construction is called Tor Alva. This is Rätoromansch for White Tower. It's a theater project together with the rehabilitation of the hotel in the background in this village of Moulins, where there are 17 inhabitants. The tower consists mainly of 3D printed concrete. The client was the theater group Origin. It's a very highly esteemed theater group, successful, appreciated, and his director, Giovanni Netzer, contacted the architect Benjamin Dillenburger and Michael Hansmeier. Dillenburger is professor at ETH in Zurich, and together with the chair of Professor Kaufmann, also ETH Zurich, they developed a way to 3D print these columns of the tower. And it was our job to create a structural system out of the ideas of the architects and detail that through all the stages. This is the robot printing a column. This is the result. You have walls of about 25 millimeters thickness. The height of the courses is about 15 to 20 millimeters. And you see this is a rough structure, concrete made of small aggregates with some admixtures. Structural principle in the horizontal section. You see loops of reinforcement. These loops were prefabricated, welded, and there was a second arm of a robot which in the right moment put the loops into the fabrication process. Longitudinal reinforcement, of course, had to be added afterwards. So you see here 4 longitudinal bars which are grouted in their channels. Another image of this 3D concrete. You can see the way of the robot going like that, and so on. And also you have an idea of the loops, which are stainless steel, which are afterwards filled with the grout. A section through the tower. The upper 4 levels are made of these printed columns, and then there is a cupola. This picture shows you some of the specialties. There is one element consisting of a prefabricated concrete plinth, of a shaft in printed concrete, and a capital, again, prefabricated reinforced concrete. These elements, plinth, shaft, and capital, are connected by these longitudinal reinforcements with end discs, and on the upper levels also with a small post-tensioning. You see rings going around, which will take in winter a protective membrane, translucent. This is the cupola. Again, you can see these elements. Capital, plinth of the next elements, and they always overlap, and they are screwed together. The structure is thought to be temporarily used, and it can be dismantled by losing these screws. But the fixed elements are always per floor, plinth, shaft, and capital. At ETH, prototypes were tested thoroughly by the chair of Walter Kaufmann, and the results were very satisfying, also in shear and bending, but in the tower itself, we looked for a concept that acts mainly on normal forces, with small bending moments and shear forces. A view on the assembly site with these elements. Parts of the cupola with some post-tensioning visible. The 6-meter-high columns of the 4th floor in the assembly workshop. These are 3 printed elements put together and post-tensioned. This is the introduction of a coated post-tensioned rod, 12 millimeters, with a post-tensioning force of 124 kilonewton. So the assembly of the tower went well, but almost a year before, beginning of November, I got a phone call from the billing side, and they told me, your columns are cracking. I immediately went up, and I saw this. There were very regular ice blocks coming out. Of course, we had discussed about the frost resistance of the surface of the elements, and therefore it was decided to put these membranes around the tower. But this we had not foreseen. Immediately, I called for a workman with a drill, and we put drills on all the cavities. And as you can see here, at some places, fountains of water came out. So it proved to be the adequate measure. And in the evening, we had put these drills into all the hollow parts of the columns. Fortunately, there was not an immediate danger for the structure because the reinforcement was more inside. It was just the outer skin which was affected by this. So we were just lucky. Yeah, I went into the office and Gianfranco Bronzini and I discussed what was there. How could this happen? And then he said, look, the problem is you are an experienced engineer. You think of 3D concrete, but in fact, it's 3D printed mortar. And 3D, it's a question of wording. 3D concrete, 3D printed concrete is watertight when it's not cracked under compression. 3D printed mortar is a different thing. And in fact, we looked for locations where the water could penetrate into it, but we did not find it. So it's the material itself which is not waterproofed. It's not vibrated concrete and so on. So the water could get in, but it could not get out enough at the base of this. Yeah, this was something I hadn't thought before, that experience means you have done something. But experience is not insight. Experience is good when you repeat things. But experience can blind you, and general experience is overestimated. Just an example. When there are competitions, often there are these pre-selections. How do you pre-select people for a competition? It's based on experience. This is stupid. I always vote for open competitions if I can. Experience. Experience hinders innovation and hinders thinking. I remembered how I was somehow shocked some 5 years ago, listening to a lecture of Aaron Ronald Bodenheimer at the radio. I just wrote it down after the radio speech of him. Psychiatrist and psychoanalyst. And he said, observation is one of the most mind-numbing activities there is. Beobachten ist eine der verdummendsten Tätigkeiten, die es gibt. And I was shocked because when I was a teacher, I always told the students, go out of your offices. See reality outside. Watch, observe. And now he comes and says, this is very super. So this made me think. Of course, he thought not about construction, but anyway, in a very general matter, he claims that we have, or the postmodern society has a discomfort with thinking. And we put observation before thinking. And then I remembered Karl Wilhelm Ritter, 1899, the Hennebick system he described. And he made this sketch above left. This is purely speculation by Wilhelm Ritter. And as he says, comparative tests would be appropriate here. But we see it's the thing we apply today, foreseen by Wilhelm Ritter by speculation in 1899. And maybe the strategy we can take from that is think before test. This is the introduction to the graphische Statik by Karl Kuhlmann. And Der Zweck sollte sein, vor allem denkende Menschen zu bilden. The purpose should be, above all, to educate thinking people. So, go ahead, thinking.
Thank you so much. For sharing this experience, and the own learning, and maybe re-questioning and rephrasing something what we believed in very long. Who would like to discuss, add a question, a comment? I think this really needs a comment, or a protest, or approval.
Lieber Jörg, dear Jörg, thank you so much for this interesting, exciting arguments about thinking. But I don't know if my expression corresponds really to the sense when I say, is it a danger that you throw the baby out with the bathwater? So I mean, what is the difference between thinking and to integrate experimental and experience in thinking? You are experienced engineer, but this avoids not that you are able to think.
Yeah, of course, things are always a bit complicated, more complicated than one says, but I try maybe to make the distinction between experience, as every project has some repetitive parts where you can rely on previous experiences. I think that's the worth of experience. But thinking is something quite different. That's just formulating a problem and looking for a solution. And I think that has nothing to do with experience. I remember some examples in our country with projects where experience led to a certain way, and after a while you have the feeling this is wrong, this is just not right, and then you have to step back and think, what is really the task of the thing? And then I think by thinking, maybe abstract thinking, you come to other solutions which are better. I could explain that with examples, but this needs a bit time. Yeah.
If I may, Jörg, thank you so much for your words. But just on this point about thinking, we all are engineers, I imagine, most of us are at least, and we deal in a world of uncertainty. We deal in a world of risk and unknowns. That's our job, to try to define those things. And we all know that the problem is the unknown unknowns. That's where we have to think. Experience deals with the known unknowns. Yeah? That's where experience is really helpful. But our big problem is the unknown unknowns. And any big project, any project, has potential unknown unknowns. We heard about the Messina Bridge earlier. I've spent 30 years working on that project, and one of the reasons why it's not developed faster is because there are lots of unknown unknowns when you go to scale. And that's where you have to think and do lots of research and lots of understanding.
I agree.
Another comment? What I think is very important for me is the lesson I learned from your presentation now is that sometimes, in a way, to reduce more or less the complexity to one task Yeah, it is the task of thinking. Yeah, just to think, not always to think in the complex situation that we are then to transport it in reality. So in a way, I can also take that as a reduction and really going back to just one more or less method of doing something. You don't agree?
No, that's a bit a dangerous reduction, maybe. Yeah.
Yeah, maybe we need to discuss that. So if there is one more question. That would be the last one then.
I agree that thinking is a very important thing, but what if your thinking goes against the mainstream narrative? How will you act in that situation? Imagine you want to apply for a project financed by the government, but it doesn't align with the government purposes.
I had an acoustic problem. Can you?
Could you repeat it, please?
What if your thinking goes against the mainstream narrative? And I mean, just as an example, very abstract, but still, you want to get some funds from the government, but your research or project doesn't align with the government purposes. How would you act in that situation if you're not really free to think?
Yeah. Somehow this is what you are looking for, to have a solution which has not been predicted. I think this is the creative aspect of thinking, and if the solution is good, what I hope, then you are prepared to convince people, or the idea is prepared to convince people, not mine.
Thank you again, Jörg, for this inspiring lecture.